All right, the second situation we have here now more strongly resembles one of these first two parts. We've got the integral from 1 to 2 of dx over x minus 2. And if you put the 2 down here in the bottom, that's where we're going to get our 0. So we can't use that 2 as part of our limit. That's what makes it improper. And we're approaching the 2 from the left. And so the setup then for this guy is going to be the limit as b approaches 2 from the left of the integral from 1 to b of x minus of dx over x minus 2. And this is also a situation where we're going to have to take an integral, and because the x part is just x, it's not 2x or x squared or 3x or something like that. When we take this integral, it's just the straight up natural log. It's no different than looking at the integral of 1 over u times du. It's going to be the same thing is going to happen. Okay, this guy becomes the natural log of the absolute value of u. Okay, the same thing here, because when you take derivative of x, you just get 1. So our limit then is going to be b approaches 2 from the left of the natural log of the absolute value of x minus 2 evaluated from 1 to b. And it's stop minus start. So this is going to be the natural log of the absolute value of b minus 2 minus the natural log of 1 minus 2. Okay? And so when we sort this guy out, what we're going to end up with is the natural log of 1 minus 2, the absolute value of that. Well, that's 1, right? Because the absolute value of negative 1 is 1. So you get the natural log of negative 1. Absolute value of that is 1. The natural log of 1 is 0. So that just leaves me with this guy over here, the natural log of b minus 2. Well, 2 is approaching, I don't know why I wrote a minus 1 here. We're just coming in from the left. 2 is approaching from the left. In other words, we're at like negative 2.00001, negative 2.0000001, negative 2 blah, 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 blah. And so what's going on here is we're getting really, really, really tiny numbers. So we're looking at the natural log of the absolute value of a really small number in here. So I'll go ahead and write this out. Let me move that a little bit. So we would say minus this. Okay, and then think about what's happening with your natural log in this case. As we get smaller and smaller numbers here, okay, we get closer and closer to 2, then the numbers inside the natural log are very, very small. And small numbers inside a natural log actually approach negative infinity. So if you get your calculator out and you punch in natural log of 0.0001 and get an answer, and then do the natural log of 0.000001 and get an answer, what's going to happen is this guy right here approaches infinity, negative infinity. Okay, and so we would say that this particular integral then would go to negative infinity. And since it goes to a negative infinity, we can say that it diverges. It doesn't converge on a specific number value. So there you go. There's another improper integral situation. Again, the math is not hard for this particular one. The algebra is not too bad, but you do have to be aware of what's going on with natural log as you're really close to 0.